All right, so with this section, we're going to be looking at all of the different tests that we have worked with so far, and we're going to see, based on what our sequence or our series look like, we're going to determine which convergence test should we apply. All right, so here we want to determine whether the following sequence converges, and we want to justify our answer by explaining which convergence test should we apply here to decide if it converges, okay? So if we take a look at what we have here, we can see we have this -1 raised to the k power, okay? So that means our function is alternating, right, based on our sign, okay? So let's kind of make some notes here. All right, so first we can say that the terms, they will alternate in sign, right? And that just simply means either it's going to alternate between positive or negative k, depending on what our k does, okay? So our key word here is alternate, so maybe we have an idea of which test we should apply, all right? Now, another thing is we can see that our function, our sequence rather, series, is going to be non-increasing, all right? So if we think about what our a sub k plus 1 is, right? So replacing and of course we're going to look at the absolute value here. So replacing every k that we see here with a k plus 1. All right, so of course the absolute value of that is going to give us a positive value, okay? So it's positive, and then we can see that it's going to be less than or equal to our AK, okay? And so remember, our AK here, of course, if we take the absolute value, it's just simply k over 3k to the 6 plus 1, okay? So what does this mean, right? So this means that our terms in our series are non-increasing. Okay, so in other words, they are decreasing, all right, as our k grows, okay? So non-increasing in magnitude. All right, and then what else must be true here if we're kind of thinking about the alternating series? Then the limit, all right, as our k goes to infinity, we do the absolute value of our series here. Then we have the limit as k goes to infinity of our k over 3k to the 6 plus 1, okay? So what's our understood exponent in the numerator? 1. Our exponent degree in the bottom is 0, sorry, it's 6, right? So therefore, we say the degree, all right, and our numerator is less than our degree in the denominator. So what does that mean then about our limit? That means our limit is 0, okay? All right, so based on each of these three conditions here, then which series or which test, which convergence test should we apply here to decide that it converges, okay? So based on all three of those conditions that we have here, we can say that our series converges, okay? All right, and how do we justify our answer? We say it converges by the alternating series test. All right, and so there we go, okay? So that's how we were able to decide which series or which convergence test that we should apply there to decide that it does indeed converge. All right, so let's look at this series here, see if we can decide if it converges, and then if so, we're going to justify the answer by explaining which convergence test did we apply, okay? All right, so if we take a look at what we have, we don't have any factorials in here, but we also don't have a -1 to a k or a k plus 1, so we wouldn't have to worry about the alternating. And then if we notice that we don't have everything together raised to a certain power, so it wouldn't be the root test. So how about we apply the ratio test, okay? So let's see if we can apply the ratio test with this one, okay? So remember, we need to have the absolute value of k plus 1 over ak. And so then take a look at our place of the k, so everywhere we see a k, we're going to add a plus 1. So we have a k plus 1 to the 4th over 4 raised to the k plus 1. And then, of course, since we would be dividing by this entire ak, how about we just go ahead and multiply by the reciprocal of that. So we have 4 to the k over k to the 4. Okay. All right. So let's see how will this simplify. So we got this k plus 1 to the 4. Then the bottom, we can go ahead and realize we have this k plus 1 as our exponent, so we can rewrite the bottom as k to the 4 times 4. Then we still have this k to the 4, or 4 to the k and k to the 4 here, okay? All right, so then what do we notice? The 4 to the k's simplify, so we end up with k plus 1 to the 4 over, then we still have a 4 in the bottom and a k to the 4 in the bottom, okay? All right, so now the ratio test says, all right, well, let's find the limit of that. So we have that limit as k goes to infinity, and we now want to do the limit of our entire thing that we have inside here, okay? So the limit of k plus 1 to the 4 over 4 times k to the 4, okay? All right, so let's see if we can decide what this limit would be. Well, if we were to pull this numerator out, then the degree in the top would be k to the 4, right? Then, of course, we would have some other terms here, but we don't, we're not concerned with the rest of the terms because we just want to know, okay, what's the degree of the numerator? And then, of course, if we look at the bottom, we can see that the degree is 4 as well. So the understood exponent, or the understood leading coefficient here for the numerator is 1, and then of course the leading coefficient, the denominator, is 4. So since the degree and the numerator is exactly the same as the degree and the denominator, then what does that mean? We look at the leading coefficients, right? So we end up with 1 over 4, okay? So the ratio test says if that limit is less than 1, then the series converges, okay? All right, and so to justify our answer, we say that it converges by the ratio test. All right, everybody, so let's take a look at this example here. So again, we want to determine whether this series converges, and then we're going to justify our answer by which convergence test that we apply, okay? So if you take a look at what we have here in our denominator, we have this e to the square root of 2k, and then we also have something similar here, the square root of 2k in front. All right, is what we have for our exponent. So maybe this kind of reminds you of a function that we could possibly integrate. Okay, so what if we rewrite this as a function of x? So we can replace our k with x. So we have 2 over the square root of 2x times e to the square root of 2x. Okay, so maybe when you look at that, you can decide that, okay, possibly I could integrate that. All right, so what we're going to do is we're going to rewrite this summation as the integral from 1 to infinity, and then of our function, so 2 over the square root of 2x times e to the square root of 2x dx, okay? All right, so if you notice, we have infinity as our upper bound, and so what we usually like to do is we want to rewrite that where the upper bound is now b, so then we put that limit in front as b goes to infinity, and then rewrite our function as it is inside of our integral. All right, so now let's see, how could we possibly integrate this? Okay, so if you want, we could go ahead and bring this 2 out to the front of the integral. So we have the limit as b goes to infinity of 2. All right, then the integral from 1 to b of now just 1 over the square root of 2x times e to the square root of 2x dx, okay? All right, so now when you take a look at what we have here, again, we have our square root of 2x as the exponent and that similar thing in front of the e, so maybe that reminds you of applying the u substitution, okay? So let's let our u be what we have there in the exponent, so the square root of 2x. Then we can rewrite that as 2x to the 1/2. And then, of course, once we find our u, we can then find our du, okay? So we would have 1/2, keeping the 2x inside, remembering to subtract 1 from the exponent, and then this should remind you of the chain rule, okay? So we also have to take the derivative of what we have on the inside, and so that would just be 2, okay? So now you can see that our 2's cancel out, so now our du is just 2x to the negative 1/2, or we can rewrite that as 1 over the square root of 2x, okay? So again, remember to keep the dx with that. All right, so that looks exactly like everything that we have here in our function, okay? So let's go ahead then and see if we can find the integral. So we got that limit in front as b goes to infinity. We have the 2, okay, that we're going to keep. And now we're going to rewrite our integral in terms of u and du, okay? So when we do that, we get e to the u times our du, okay? So just that simple. All right, so now let's go ahead and find the integral, okay? So again, that's in our denominator, so 1 over e to the u, okay? All right, so we have it now in terms of our u, so we are ready to find our integral, okay? So keeping the limit in the front, haven't done anything with that just yet, and so now we can rewrite this as e to the negative u du, okay? All right, so what do we get? Limit as b goes to infinity, we have 2 times, and then of course find the integral of our e to the negative u, and what is that going to be? E to the negative u, but then you have to remember to divide by that negative 1, okay? So then evaluating that from 1 to b. So we have the limit as b goes to infinity. We have negative 2 over e to the u, okay, evaluating from 1 to b. All right, so now go ahead, plug in the bounds. So negative 2 over e to the b, then minus negative 2 over e to the 1. Okay, so we are ready to do our direct substitution. So now go ahead and let this b go to infinity. And when we do that, we will see that that entire piece will go to 0, okay? But one thing that we have to remember to do is we got to remember to put that u back, okay? So remember we said u was the square root of 2x, okay? So here we should really say, all right, the square root of 2x here with the b plugged in, and here the square root of 2 there with the 1 plugged in the place of the x, okay? All right, so again, we will see that as our b gets bigger and bigger, this entire fraction here goes to 0. So we have that limit as b goes to infinity. Actually, we already have let b go to infinity, so now what do we have? We have 0 inside here. This is a minus, right? So plus 2 over e to the square root of 2. All right, so what do we get that limit to be? 2 over e to the square root of 2. All right, so here, based off of the integral test, we say that our series converges. Okay, so again, converges by the integral test.